So the first two exercises were a bit of a warm-up, heading toward the main event, so to speak. The next exercise is more a major example, and it goes like this. We want to evaluate the integral where we have x cubed multiplied by sine x dx. So this look innocently enough. Turn out that we'll have to go through 3 different steps here. Okay, so we look at this in general, and we are looking for, I'd like you to find a formula that we can work with to begin. So look for the group of trigonometric integrals. I think this group starts in 63 and run all the way to 86. So between 63 and 86, you should find 84 is correct. So 84. So let's see what 84 tells us. 84 tells us that in general, whenever you have u to the nth power sine u du, which is really what we need, then the solution will be negative u to the power of n cosine u plus n times the integral of u to the n minus 1 cosine u du. So kind of obvious that we have integration by part here. Well, we do have integration by part, as we have a power function multiplied by trig. And as a result, every time we integrate by part, we reduce the power. You see that in this step we reduce it from the nth power to the nth minus 1 power. All right, so in this case, we are looking at n equal 3, and therefore the integral of x cubed sine x dx will be a negative x cubed cosine x plus 3, the integral of x squared cosine x dx. So now we need to deal with this integral. We don't have to worry about the 3. We'll take care of it at the end, later on. We'll put everything together. So which formula are going to help us here? That was quick, but it's also correct. By formula 85. That's where we're going to find. So it's the next formula. That's why it was convenient. So this formula tells us that the integral of u to the n cosine u du equals u to the n sine u minus n, the integral of u to the n minus 1. So that's another reduction, sine u du. So in this case, n equals 2. So the integral of x squared cosine x dx equals x squared sine x minus 2 integral of x sine x dx. Okay, and now in this step we need to take care of the integral of x sine x dx. This is a classic integration by part, but again we have a formula for that, so find out this formula, please. Go ahead. I heard somebody whispering it. 82 is correct. So in this formula we have the integral of u sine u du equals sine u minus u cosine u. This is what I was talking about when I said that we really know how to do each one of the 147 integrals. And this is something that is very obvious. So the integral of x sine x dx equals sine x minus x cosine x. So we have all the components together, and on the next page we're just going to create the solution. Let's see if I can put it. No, I need about 4 lines, so I'll move it to the next page. So what is the integral of x cubed sine x dx? Well, it's equal to what? We started, the first solution was the first step is, where did I put it? Right here. So we had negative x cubed, right here, cosine x, and then plus 3, and now we go into the second one, and the solution is right here. So 3 times x cubed sine x minus 2 integral of x sine x dx. And now we can go ahead and clear everything. So minus x cubed cosine x plus 3x cubed sine x, and here we have minus. So let's see, what was the last integral? Sine x minus x cosine x. So we have minus 2 times what we had before. 3 times 2 is negative 6, and we have this one right there. So it will be minus negative 6 times sine x minus x cosine x plus c. And one more thing before we'll finish this up, you can see, no, actually it's not. This is 3x squared, I believe, isn't it? So we have x squared right here, and yeah, that's what attracted my attention. Notice that we have x cubed, x squared, x, and a component, a trig function without the x. So let's write it just for cosmetic reason in descending powers of x. Okay, so we have negative x cubed cosine x, and then plus 3x squared sine x, and here we have we have double negative, so this becomes positive. Positive 6x cosine x, and finally the free component, the term without x, and that will be the answer. Okay. So I organize it a little bit, as I said, just for cosmetic reason. So if you look at this particular exercise, we went through, we used 3 different formula, although the last one was really not necessary. Okay? 3x squared, right. Let me just make sure that it's clear. Okay, so you have x squared here. Oops. Here we go.